In this section, I'll be providing a demonstration of how our program works from the user's perspective. So, this is going to be split up into two parts since our program can be used by either the users or teachers who want to create physics problems for students. So, for both cases, you're going to want to go to the link first and you'll be met with this menu screen. So, we're going to do students' point of view first. So, you're going to want to press the start button and here you'll see the problem selector. Here you can filter out different problems and you can sort by difficulty. When you click a problem, you'll be met with the subject's difficulty, a short description or instructions for the problem, and the title. You can enter the problem by pressing start, but for now, I'm going to tell you a little bit more. So, if there's lots of problems, you're going to be able to press previous and next to see different pages. Alright, now that that's over with, I'll show you a problem. For this demonstration, I'll be showing you projectiles in projectile motion. So you can see all of this stuff and you can press start. So here we're given a set of givens and solves. So in the givens, this is stuff that you might need to know to solve the problem. For example, gravity or distance that the box travels. And here you'll input your solution. If you want to see instructions for the problem, you can press view problem and it will tell you here. So here we're supposed to calculate the initial velocity of an object being launched off of a table. I already know the answer for this problem, but if students did not know this, they would need to use physics formulas given by their teachers or just Googled online to be able to solve them. Something to note is the item indicators right here. So right here you can see solve and A, X velocity. So that means A, like item A here, which is this item, you can see that by the indicator, and you're inputting its X velocity once you press start. So if I were to press start right now, since it's 0, nothing will happen. And after 5 seconds of inactivity, it'll reset on its own, or you can just press the reset button like this. Alright, so I already know the answer to this problem, but I'll demo what happens if you put an incorrect solution and a correct solution. So if I put an incorrect solution, say -5, it'll go that, and it will basically do nothing and reset on its own once it finishes the 5-second timer of inactivity, that is. For a correct solution, which is 6.2, you can see that the item will fall onto the target and you'll get some confetti to show that it's right. To go back to the main menu, all you need to do is press the back button and you'll be back to the problem selector. So if you're a teacher who's creating problems, all you need to do is press the problem creator button and you'll be met with a pop-up saying this is difficult to use on mobile and is not for student use. It is still usable on mobile, but it is difficult, as it says here, so I recommend that you use a computer. Once you press the button, you'll be met with a blank screen and a bunch of buttons. It may seem a little daunting at first, but it's actually pretty straightforward. At the top right here, there are 4 buttons you can use to create different types of objects in the system. So one thing that you should always have is at least one friction zone, because that acts as like the collision box for the ground. If you don't want any friction, you can still set the friction to 0. That'll make it so that objects will slide forever, and friction is not something you need to consider for the problem. To add a dynamic box, which is just a box that will move, you can just press new dynamic box, and to select it and view its properties, you can click it. Here you'll see a list of all of its properties, and you can change them however you want. So for example, if I want to make it wider, I can do that. If I want to make it taller, I can do that. Something that should be noted for dynamic boxes on ramps is to place them on top of it, it may be a little bit strange. So since the hitbox of a box isn't actually on top of the ramp, it's kind of inside the ramp, and don't worry, I'll show you that in a second. You might think you want to place it like this, but that'll kind of give you some weird behavior like this. What you want to make sure is that the green box is actually on the ground. That way the box will act how it should and no problems will arise. By the way, you can change IDs of boxes and other items by just changing the ID just like that. This is purely cosmetic, but it is useful when you create new collisions or givens, which I will talk about later. Once you have a situation you're proud of, you can start adding solutions and givens. The first step should be to calculate the actual values required for this to work in a separate piece of paper or online. You can use a calculator, it doesn't really matter. All you need to do is make sure your numbers are correct. Here, I use a stopping distance calculator to figure out the coefficient of friction on the ground needed. So I can just copy this value here, or I can just approximate it so it looks like it's about 0.23. So that's the number I'm going to use. So now I can get that value, 0.23, go to ground and set it to 0.23, and then I can press the drop-down menu and make sure I've selected friction. Now I can press make solution, and if I go into preview, you'll be able to see that I can change the coefficient of friction on the ground. In my calculation, I used an initial velocity of 6 meters per second. So to set that, I will add negative 6 meters per second just because it's going left. If it were going right, it would be positive. And now I can go to X velocity in the drop-down menu and press make given. Now, if I go into preview, you'll be able to see X velocity negative 6 meters per second, which means it's going that way. Since the distance traveled isn't necessarily an attribute directly linked to this box, I'm going to need to add that in a section called the collision/givens. So I can enter this section, and then this is this section I'm interested in right here. So I could say distance between box and target. And then I would put a colon. And then since we know it's 8, I put 8, and then another colon, and then meters. There's an example right here. It's basically just title of given, the value, and then the unit of the given. And once I've typed that out, I can press new given, and I will be able to see it right here. Once your program is finished up, you can press program details, add a title, which I'll just do stopping distance. I can add instructions. Once I finish my instructions, I can set a difficulty rating. I think this is a pretty easy problem, so I'll select easy. Then I can select some physics subjects that I think are relevant to this problem. So for this one, I think friction and kinematics are relevant. Once I've done that, I can exit this section by clicking anywhere outside the box, and then I can preview the level. This will be the final level. So you can actually, this is fully functional, you can toggle the forces, you can view the problem, and it all works well.
So I'll start with our index.html file. Basically, our files are split up, I'd say, pretty well. We have assets, which is all of our images and all of our sprites and whatnot. We have the images for just all the things in general, and then we have, this is specifically for the menu sprites, and then there's some unused assets here. And then we have our index.html file. This is where all of our HTML is in. Our program actually has a two parts. So there's the canvas area over here, which is all JS, and then there's this column on the side which is actually HTML. So all the buttons, all of these check marks, whatever, all the buttons here, all of those are created. Everything here, all of that is created in this HTML file. It's all buttons, whatnot, and then this script here is specific to the problem creation page, to this page. When creating problems, this is for all the attributes of the items. When you're able to select all the attributes, say the dynamic box, you have all these attributes, you have all these things that you can change. This whole script from 316 to 600 is solely for changing those attributes and grabbing them and sending them and whatnot. And then we have the script for everything else related to any buttons being pressed on the HTML side of the screen. So you have the start button from the main menu. There's a problem creator button. The start button will run this function. There's a bunch of other buttons, show forces, preview, whatever, copy level data. And each of these functions are for one of the buttons on the HTML side of the screen. And then for all of our buttons and whatnot, we have a style.cs or style.css folder. This is for all of our classes for our CSS, and then we'll create them here, and then we can give classes to whatever we want in our HTML folder. So it's a lot simpler. instead of giving them a bunch of styles for every single one, we can just make a class and whatnot. And then we come to our main, where the majority of the code is in the three JavaScript files. Main, there's a little less. Main is where we declare all of our variables, and we have our draw function, which is drawing everything on the canvas part of the screen. And it's based off levels. So level 1 is the menu screen, level 2 being the level selector screen here. Level 3 is once you choose a problem, this is the problem screen, so on and so forth. There's another level for the problem creator screen, and they each have their own designation in here with each of their things. And then that's all of draw. And then if we come to classes, this is where a lot of our code is here. So classes is where we have all the classes for our items. We have the main parent class, which is for static and dynamic boxes. It's the item class, and this just has all your basics, your ID, your X, Y, width, height, that both of the static and dynamic boxes will have. And then it has some functions like get motion, direction, get net forces. It has our elastic collisions function in it. And then underneath there is the dynamic boxes, which is a subclass of the item class. And the difference is that the dynamic boxes class has mass and it has velocities as well. And then it inherits the other stuff from items. And then, so because this box has movement, and then there is also a static box, which is pretty much the same as a moving box, except instead of movement, it has a friction coefficient. And there's also a ramp class, which is for our ramps, and it's got a bunch of different things. It is not a subclass of the item like the other two are, because this one doesn't really take much from it. Everything, all the attributes of it are quite different. Another thing to note is all of our collisions and whatnot are inside of the dynamic box class and the static box class, I'm pretty sure, but a lot of it is in the dynamic box class. And then if we go to functions, this is where all of our other important functions are. We have our sort function. Our preload function is important. It'll load all of our images before the program runs. And then we have setup to create the canvas and read our CSV file. And then we have some other functions. Load level is an important one. Load level determines which level is loaded when you get to this screen. And it takes a level ID, and that will determine which level is loaded, and it takes that ID and it will look through the CSV file or what is read from the CSV file, and it will read everything from there, and it will send all this stuff to draw, and it will create everything that is on the canvas. And then unload level is here to, when we're swapping levels, we want to unload the old one. There's some other functions, Windows resize. Mouse pressed deals with all of our mouse triggers. There's actually quite a lot in there. And then we have a unit and a D unit, because on our screen, one unit is a box. It's 64 pixels or 32 pixels. And we want to have, it's much simpler if it's in like 1, 2, 3, 4, 5, instead of like how many pixels. It's a lot easier if we can just count by boxes. And then create level from list is an important one, because this is for the problem creation screen, this one here. And this is when you hit copy level data, it'll take everything on that you've added to this screen, and it will format it into the CSV format and then copy it to your clipboard. And speaking of CSV, This is our CSV file, and it has all of the store levels in here. This is a level, this is a level, and once you have that data copied, you can just paste it into the end of the CSV file, and it will add another level for you. And that is that. There's also a not really a README, but this is an old file that we had for when we were using the CSV. It basically says what, it basically describes what each thing in the CSV file refers to. So if you want to know that, there's this folder here.